Graph Theory Class 10 Video 4. In this video we're going to talk about colouring graphs, and in particular we're going to talk about a very important algorithm called the greedy colouring algorithm. So let's begin with the definition. The greedy colouring algorithm is an algorithm for finding a colouring of a graph. And the one word I want to really highlight in this definition is the word A. Okay, so this algorithm, you give it a graph, and it gives you a colouring of the graph, and it's a proper colouring. So no neighbouring vertices have the same colour. But that's all it promises to give you. It doesn't promise to give you the best colouring or the most efficient colouring or anything like this. It just gives you a proper colouring. It doesn't violate the rule where neighbouring vertices have to have different colours. Okay? And how does it work? Well, the steps are here. The first thing you do is you order the vertices. And by this I just mean like you assign numbers to them, like 1, 2, 3, 4, 5, 6, 7. So you put them in order. And just a side note, I will probably be doing this for you. So when this question comes up on homeworks or exams, the vertices will probably already be numbered. Okay, so I'll tell you which order to use the vertices. And then you order the colors. And this is like a technical issue. It's because this algorithm, it's used by computers, and computers like things to be in order. So we need to order the colors. And instead of trying to agree on an order between like red, magenta, pink, and orange and stuff like this, you do the convention where you just call the colors A, B, C, D, E, and so on. Okay, so my colors are A, B, C, D, E. That's what the colors are called. And this is convenient because most people know the order of the alphabet. So they're already in a nice, intuitive, natural order. Okay, so that's just setting up the stuff. Now let's get on to the actual steps of the algorithm. So the first thing you do is you color the first vertex the first color. So whatever vertex was number 1, you color it A, because A is the first color. Okay, and then each subsequent vertex you color the least color that's not already assigned to a connected vertex. So like for number 2, you color it A if it's not connected to number 1, or you color it B if it is connected to number 1. Okay, so in each step you color the vertex the lowest permissible color. I think it's easier if we just do an example to demonstrate this. Okay, so here's an example. Apply the greedy colouring algorithm. Apply the greedy colouring algorithm to these two graphs. Okay, so as you can see, I've already numbered the graphs. I've already numbered the vertices. Okay, this question, it comes in two parts. Like this is part A and this is part B. So I've already numbered it for you. So that means you just need to go straight ahead and apply the algorithm. So you colour the number 1 vertex with the first color, which is A. Then you color number 2 with the least color permissible. Well, you can't color it A because it's already connected to an A. So that means you have to color it B, because B is the next smallest color. Okay, now number 3, you can't color it A and you can't color it B. So the next smallest color is C. Number 4, well, number 4, the smallest color is A, and that's perfectly fine because this is not connected to anything which is colored A. So you color it A, not B, because A is a smaller color than B. And finally, number 5, you can't color it A, you can't color it B, and you can't color it C. So the smallest color permissible is D. Okay, this is the output of applying the greedy colouring algorithm to this graph with these vertex orderings. Okay, so that's the end of part A. Now let's do part B, and it looks very, very similar, right? In fact, the only difference between A and B is that the 4 and the 5 have swapped places. Okay, so the ordering of the vertices is the only difference. But let's see what happens. So number 1 is colored A. Number 2, that can't be A, so I'll do it B. Number 3, can't be A, can't be B. The next smallest color is C. So exactly the same so far. Number 4, can't be... oh, it can be A. Number 4 can be A, right? It's not connected to an A, so I can color it A. And number 5, well, it can't be A, but it can be B. Okay? So for part A, I have a B, C, D 4 coloring, but in problem B, the same graph, the answer was a 3 coloring. Okay, and this highlights a really important fact. Like I said earlier, the greedy coloring algorithm is not guaranteed to give you the best answer. It strongly depends on how I number the vertices. If I change how I number them, that changes, it has the potential for changing the output of the algorithm. Okay? I think a common mistake students make when trying to answer these questions is I tell them to apply the greedy coloring algorithm, but they think that they can find a smarter, more efficient way of coloring it, and then they just find the most efficient way of coloring it, which is great. It's very nice that they know a more efficient way, but if I say apply the greedy coloring algorithm, then I expect you to actually apply the algorithm. Even if it doesn't give you the most efficient result, I want to see that you can implement this algorithm. Okay, so even though it doesn't always give you the most efficient result, it's still a useful algorithm, and you need to know how to do it. That's the end of this example, and that's the end of this video.